Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 3 from the October 2018 Statistics S1 paper from Edexcel International A-Level. And this question here, we have a frequency table and it tells us about the parking times in hours, T, for cars in a car park, and the frequency table is given here. You've got the time given in groups, the frequency of the number of cars in each of the groups, and also they gave us the midpoint of each of the groups, which might come in useful. And they gave us some summary data, the sum of f times the midpoint for the total sum of all the f times the midpoints, and the sum of f, the frequency, times the square of the midpoints, which might come useful for things like mean and standard deviation. Then it says a histogram is drawn to represent these data. The bar representing the time 1 to 2 has a width of 1.5 centimeters and a height of 6 centimeters. Calculate the width and height of the bar representing the 4 to 6 category. Okay, so now this is a very typical type of question. So they've given us information about the 1 to 2 bar, and they want us to calculate the information, the dimensions of the 4 to 6 bar. And they gave us information about the width of the bar, and they gave us some information about the height of the bar. Okay, now the width of the bar is determined by the interval. Okay, and the height of the bar is determined by the frequency density. So when they're talking about width, I'm going to talk about interval. So the width, I'm going to mention here the interval, which is the width of each, which is the how wide each interval is. And for the height of the bar, well, the height is determined by the frequency density. The frequency density. Okay, so the interval for, I'm going to concentrate on just these two. I'll just carry on the highlights so we can, I'm going to continue with these two. All right, these are the two I'm going to concern with. I'm not really concerned with the rest of them because we have to only deal with these two. So this is what we know about the 1 to 2. We know that the interval here is 1, and the frequency density here is 18 divided by 1, which is 18. So here the frequency density is the same as the frequency because it's the frequency divided by the interval. Here the interval is 2, between 4 and 6 is 2, and the frequency density is 12 divided by 2, which is 6. Now, so let's put the one that we're trying to find the dimensions for on the top. So we're going to talk about the 4 to 6 bar on top. Okay, and we know the 4 to 6 bar. We're going to let's first deal with its width. Okay, so let's deal with the width first, and then we're going to deal with the heights afterwards. All right, so let's think with the width. We have the 1 to 2 bar. So what I know is for the 1 to 2 bar that they've told us that 1 centimeter, 1.5 centimeters represents an interval of 1 unit. 1.5 centimeters is representing 1 unit, and we want to know how many centimeters. I'll call it W. W centimeters is going to be representing, and we have to for the interval of 2 here, 2 units. The 4 to 6 bar is 2 units wide. Okay, so we can see that's pretty simple here. We have to just cross multiply. So we can say W is equal to 1.5 times 2 over 1. So that's 3 centimeters, simple proportion. So we know the width is 3 centimeters. Okay, and for the height, all right, so the 4 to 6 bar, we want to find its height. Okay, and what is the thing that determines the height of the bar? It's the frequency density. So the height of the bar that we're looking for, which is this, is 6 centimeters, is frequency density. We want to know what height represents 6 units of frequency density. Okay, 6 units of frequency density. So we want to know what is the height in centimeters that represents 6 units. Okay, let me just write that neatly. And we know that this 1 to 2 bar, okay, it has a frequency density of 18, and they've told us that this 6 centimeters represents the 18. 6 centimeters represents 18 units of frequency density. So if we're going to work out what the height is here, we'll have 6 times 6 over 18. So that cancels with that. It gives you 3. 6 over 3 is 2. So therefore the height is equal to 2 centimeters. So that concludes question number 1 part. Number 3 part A. And there's the answer there for that question. And now we're going to go on to part B. Okay, so part B says use linear interpolation to estimate the median parking time for the cars in the car park. Okay, so the median parking time for the cars in the car park. So you have to use linear interpolation. So the first thing we need to do now, when we're using linear interpolation, we need to go back to the table and we need to see how to find the median, which is the middle entry when they're arranged in order of size. Now, they did not tell us how many cars are there total in the data, right? So we have to here add the frequencies together. Normally, sometimes they say, this shows, the parking times for like 100 cars or whatever in a car park. So you don't have to add them together. But here they didn't tell us how many cars are in the survey, so we have to add them together. So we have 28, and 28 plus 12, that's going to be 40. 40 plus 15, that's 55, that's 60 cars. Okay, let's just make sure that's 17 plus 15, that's 32, that's 40, 50, 60. Yeah, all right, added the other way around, so we got 60. So that's the total number of entries in the survey. So we need to find what the middle term is. The middle term, its position will be given by n over 2. So we divide 60 by 2, that gives us 30. So we're looking for the 30th entry. Now there's different methods that people use, but I use this method. When we have group data, we just divide by 2, whatever comes out, that's what we're looking for, that position. Even if it's a decimal, we're looking for that position when we have grouped data. That's for grouped data, not for data that's not grouped. If it wasn't grouped, we'll say, 30th, so we'll do 30th, and we'll look for the 30th and the 31st entry. But here we're just estimating, and we have everything estimated in groups, so we just look for the 30th entry. So I know that when we finished the first group, we're on the 10th entry. We finished the second group, we're on the 28th entry. So of course the 30th entry is going to be in this third group, 2 to 4. Okay, in the group 2 to 4. That's where the 30th entry is going to be. At the beginning of the entry, we're on the 28th. By the end of the entry, we're on that's 28 plus 15, that's the 43rd, right? 28 plus 15, 38 plus 5, 43rd. So somewhere in this group is the 30th entry. All right, so we know the median lies somewhere between 2 and 4. Okay, so what I'm going to do is I'm going to draw a little line to represent that group. And at the beginning of the group, there's 2. At the end of the group, there's 4. There's no gaps in the group. Okay, you see there's no gaps, that's fine. So we can just write 2 and 4 straight away in the top. We're looking for the value of Q2, which is the median position. We know that that is the 30th position. All right. By the beginning of the group, as we said, we're on the 28th. By the end of it, we're on the 43rd. So the beginning of the group, we're on the 28th entry. By the end of the group, we're on the 43rd entry. Okay, that means, as we can see, that the group is 15 entries wide in terms of entries. Okay, so we're going to use linear interpolation to find what the value of the median is. So we know that it's more than 2. It's going to be 2. It's between 2 and 4, so it's 2 plus. Now, what we do is we see what proportion this distance is of the whole of this width in terms of positions. So this is 2 positions in out of 15. So that's the same fraction, okay, that this will make with that in terms of 2 and, this width here. So it's going to be 2 over 15 times the width, which is 2. So Q2 is going to be 2 over 15 times 2/15 multiplied by 2. That's 4 over 15. Okay, and you add to that 2, and that gives you 34 over 15, which is 2.2667. So it's 2. Okay, next we're going to go on to part C. Okay, part C says estimate the mean and the standard deviation of the parking time for the cars in the car park. So this is where we're going to use this data that they gave us. Now the mean, you can call it X bar if you want, is basically the sum of the frequencies times the midpoints over the sum of the frequencies. So this is basically an estimate, okay, of the sum of all the values in our table. So if we go back to the table, we know there's 10 cars that were parked between 0 and 1 hour. We don't know how long they're parked for, but we say let's estimate that those 10 cars were parked for 0.5 hours, because that's halfway between these intervals. So we do that for each of these. We estimate how long they're actually parked for. We don't know the real value, but we can say that the best we can do is estimate that this is between 1 and 2 hours. So we say, let's say they're parked for 1.5 hours. So we do frequency times midpoint. That gives us an estimate of how long those cars were parked altogether. The same for each of these categories, frequency times midpoint. When you add them together, you end up with a total, which is the total, an estimate of the total time all those cars were parked altogether. And that's what this represents. The sum of all these. So this is basically 10 times 0.5 plus 18 times 1.5 plus 15 times 3 plus 12 times 5 plus 5 times 9. All of that together gives you this. So they already did that work for us. We don't have to do that because they gave that to us. All we have to do now is divide by the total of the frequencies, which we said was 60. Okay, so we take that value, which is 182, and we simply divide it by 60, and that gives us an estimate of the median. It's an estimate because we don't know the actual parking times. We had to use the midpoints to estimate that. That gives us 91 over 30, which is 3.03. So we can say that the mean is estimated as 3.03. Okay, and that's hours. That's the mean time. All right, and now for the standard deviation. Now the standard deviation is given by the square root of the mean of the squares minus the square of the mean. Okay, that's the variance. All right, the standard deviation is the square root of the variance. So the mean of the squares is basically when you take all the square numbers, or all the entries, and you square them and add them together. And that's what this represents. Okay, because the mid-interval value was the estimate of each of those, times that they parked for, and we square each of those and multiply, and we basically multiply that by the frequencies and then add them together. So that gives you 883. So 883 over the total number of entries, which is 60, minus the square of the mean. So we're going to square this value, but I'll take the more exact value of this, which is 182 over 60 before we rounded it. And that will give us the standard deviation. So the standard deviation is going to be the square root of, you're going to have 883 over 60 minus, and then I'll put this in a bracket, you've got 182 over 60, but that must be squared. All right, that will give you the standard deviation, which is 2.348. So we can say that the standard deviation, which is given the symbol, is equal to 2.35 hours. Okay, that's the standard deviation. So here we have the mean, and we have the standard deviation, and that answers part C. Now for part D, it says describe giving a reason the skewness of the data. Now we know the mean of the data was 3.03, I think. Oh no, sorry. Not the mean. The median was 2.27, and the mean is, as we found, 2.35. So the mean is the mean was 3.03. What am I talking about? 3.03, and the median was 2.27. Okay, the median was 2.27. Okay, now the skewness of the data is basically, when the data is completely symmetrical, then it's like the frequency table will look something like this, where it's kind of like a symmetrical kind of shape, a bell shape, which is symmetrical, and the mean, mode, and median will be around the same value. Then you have something called positive skew. Now, positive skew is something like this, where it's more of the values are skewed towards the lower end. So in this case, the mode and the median will both be less than the mean. Okay, but when it's positive skew, it's the other way around. The mode and the median, their value will be they will be greater than the mean. So the mode will be greater than the median, which will be greater than the mean. In this case, we can see the median is greater than the mean. Okay, you can say 3.03 is greater than 2.27. So it's this kind of case. It's this kind of case where the median is it's actually less than the mean. The median is less than the mean. Sorry. talking about. Excuse me for that. The median is 2.27 and the mean is 3.03. So the median is less than the mean. Therefore, it's this type of skew, which is positive skew. Positive skew. A lot of people are not sure how this works, but if you just think about it as, you know, when the higher the bar in terms of its frequency density, the higher the bar, okay, then like the highest bar will be always the median if there's skewed data, and then you'd have the mode, and then you'd have the median, then you'll have the mean as a smallest, the least tall of the bars when there's skewed data. So in this case, that would the median is a higher bar than the mean, okay, and when the median is a higher bar than the mean, but its value, okay, in terms of the time is less than the mean, we have data which is positive skew. But if you have data like this, as I said, in terms of the frequency, the highest bar would always be the mode. Then the next highest bar would be the median, and the mean will be lower than both of them. So in terms of their height. So if you see the value of the mean in terms of the x-axis being less than that of the median, which is less than the mode, then you'll have this data which is negative skew. So because the mean has a value more than the median, we can say the median is less than the mean in terms of its value on the x-axis. Therefore, we have this kind of situation which is called positive skew. All right, so that's how you can determine the skewness using the mean and the mode and the median. Here we have the median and the mean, so we can compare them to work out the type of skew. All right, so this is the reason and this is the description of the skew. Then it says, estimate the probability that this car is parked for more than 75 minutes. Okay, now, so 75 minutes, we got to first work out what that is in terms of hours, because this is in terms of hours. So you've got 75 minutes divided by 60. Now that gives us 75 divided by 60. That gives us 1.25 hours. That's 1.25 hours. So we've got to work out, basically, we have to include all of these. These are all more than 1.25 hours. All right, so you've got 15 plus 12 plus 5, that's going to be 20 plus 12, that's 32. So in total you have these 32. But then you have a fraction of these, all the ones more than 1.25 hours. So again, we can use some sort of linear interpolation. We can say this is the group 1 to 2. Okay, at the beginning of that group, we're on the 10th entry. By the end of that group, we're on the 28th entry. There are 18 entries in that group altogether. And we want to know from 1.25, we want to know how much are in this section here. That's what we want to know, the number in that section here. Okay, so we want to find how many is in that value. We add that number. So we want to find basically what this number is here. Okay, this is what we want to find. This value. How many entries are in this section? Okay, we don't need to know. We know what that length is. That is basically 2 minus 1.25, which is 0.75 from here to there. So we want to see what fraction of the group we have of 18. So we can see that this is x is going to be equal to, you can say x over 18 is going to be equal to, and this will be 0.75 over the total width of the group is 1. So 1, I'm talking about 1. So x is going to be 0.75 times 18. So we have 0.75 multiplied by 18. That gives us 13.5. So there's 13.5 entries altogether. So x is equal to 13.5. So we take 32. Okay, so the probability that the time parked is greater than 1.25 hours is going to be 32 plus 13.5. Okay, so you have 32 plus 13.5, which is 45.5. 45.5. Okay, that's not the probability. You've got to divide that by the total number, which is 60. For probability, you divide it by the total number of entries. Okay, so that we're finding the probability. So we divide this by 60. That's the number of cars we want the probability. So divide by 60 gives you 91 over 120. So it gives you 0.7583. Okay, so I'll write to 3SF 0.758. Okay, 0.758. Okay, there's the answer. We can say, if you want, as a percentage, 75.8% if you want. Whichever way you want to write it, that's fine. And there is the answer to question part E. Okay, so we just worked out how many cars there were altogether parked more than 1.25 hours, and we divided that by the total number of cars, which was 60. And that's an estimate of the probability that the car is parked for more than 75 minutes. Okay, so there's the answer to part E, and that concludes this question, which is question number 3, I think. Yep, from the October 2018 International A-Level Edexcel S1 paper, Statistics S1 paper. Other questions from this particular paper can be found in the playlist that will appear in this region here. Other questions from this topic of, I guess, frequency tables, histograms, okay, standard deviation. There's a few different topics here. I'll put it under histograms, and that will be in the playlist over here. And you can subscribe to my channel by clicking on this link, and you can watch the video that will appear in the top here to find out how to use my channel in order to help you with your revision and going through past papers. Thank you for watching, and see you soon.